Hello, hi everyone. Today I am going to start the class 10 topic, which is real numbers. Okay, in the last few days, I was telling you about number system. Okay, and in that the topic was real number, but for the class 9 students. So that part was completed. Now let's begin real number for class 10. Just to recall, okay, in the introduction part, we have understood what is the number, and under number what it means rational, irrational number, okay, so and so, okay, and how to draw irrational number in a real number line. So that all was discussed. Also, we have discussed basics of Euclid's division algorithm and fundamental theorem of arithmetic, but these two topics will be discussed in a detail in this chapter, okay, or in this class, okay, Euclid's division algorithm and fundamental theorem of algorithm, okay. So hold. So see, Euclid's division algorithm, as the name suggests, has to do with the divisibility of integers, okay. It is nothing but to define the divisibility of integers, how any integers can be divided. Was given by the Euclid. And also, and the second is fundamental theorem of arithmetic, okay, which we will understand, okay. So let's start. So the first topic that we are going to understand is Euclid's division lemma, okay. Lemma is a means of algorithm, okay. It is a theorem, or in a simple manner it can be said, in a mathematical manner it can be said, a statement, okay. So what is Euclid's division lemma? Consider the following folk puzzle. Okay, a trader was moving along a road selling eggs. An idler who didn't have much work to do started to work the trader into a wordy duel. This grew into a fight. He pulled the basket with eggs and dashed it on the floor, means throw out on the floor. The eggs broke. The trader requested the panchayat to ask the idler to pay for the broken eggs. Okay, the trader wants his money, or means payment that the idler has done. Okay, by the panchayat. Panchayat means a team or judge. Okay, the panchayat asked the trader how many eggs were broken. He gave the response. The panchayat means the team of jury was curious to know that how many eggs were broken of you, so that we can give some judgment. So what was his answer? He answered, if counted in pairs, one will remain. Okay, if everything will be counted in pairs, means in the twos, okay, then one will be remain, okay, one will be the residue. If counted in threes, two will remain. Counted in threes means threes in pair. Okay. Then how many will remain? Two. Okay. So and so. Counted in fours, then three will remain. Counted in fives, then four will remain. Okay. Counted in seven, nothing will remain. So what does it mean? It means The eggs that were broken were in the multiple of, can anyone say, in the multiple of sevens. Okay, so we have the total number of broken eggs is multiple of 7x. Suppose x is a variable. Okay, it is the basic thing. Okay, see, this puzzle is describing the actual phenomena through which Euclid has discovered. Okay, so this is a common puzzle. Okay, with which the author is trying to teach you. Okay, so I am trying to describe this. So by basket cannot accommodate more than 150 eggs, and also one thing, that his basket cannot accommodate more than 150 eggs. Okay, so anyhow, the means what trader must have eggs less than or equal to 150 eggs. This is the first condition, less than or equal to 150 eggs. Okay, suppose this is eggs, and it should be the multiple of also 7x. So can anyone think what should be the number? This is the puzzle. Okay, see, math is all about puzzle and logic. Okay, so if you are able to solve the puzzle, you are able to solve maths, you will become a good mathematician. So multiple of 7 and also less than or equal to 150, we have the condition. So the number should be divisible by 7. So any number 1, 147, I think 147 is divisible by, means its factor is what, 7 into 21. Okay, further it can further be written as 7 square into 3. Okay, 49 into 3. I think, yeah, 123. Yeah, 717, 7 to 14. So the answer should be 147. Okay, let's check out. Oh, oh. Getting back to your puzzle, do you have any idea you will solve it? Yes, you must look for the multiple of 7 which satisfy all the conditions. By trial and error, using the concept LCM, you will find that he had 119 eggs. Oh, pardon me. I haven't taken all the conditions. We need to take another conditions also. Means, see, counted in pairs, one should remain. So such conditions also has to be checked out. 2x plus 1. Okay, counted in pairs, one will remain. Counted in threes, suppose 3y plus 2. Counted in fours, 3 will remain. Okay, 4z plus 3, and so on. After this, you will find the answer is not 147 but 119. Okay, pardon me, I was wrong. Okay, but I tried. So this is the basic, not basic, but this is the start. Okay, through the NCRT. So what was the basic funda to describe this example? The basic logic behind this example was that we can describe any number, okay, any number a, any integer, okay, not any number. There are so many numbers just like rational, irrational, okay, even for real number. So any integer can be described as the multiple of any two further integers plus remainder, where remainder should always be less than or equal to divisor. Here divisor is b. Okay, this is the Euclid's division lemma or algorithm. Okay, through this we will come to the HCF and LCM. Okay, HCF means highest common factor and least common factor. So this HCF and LCM was discovered. Got the point? So let's read the exact theorem. Euclid's division lemma. Given positive integers C, it is written, it is a series of well-defined steps which gives a procedure for solving a type of problem. It is a well-defined step. Okay, means well-defined means everyone can follow this step. Okay, it will not change. Okay, person by person or thinking by thinking. Okay, everyone will follow the step. Just like sun rises sets in the west. This is the well-defined step of the sun. Okay, planet moves in an elliptical path, so and so. These are the algorithm. So such algorithm is also applied in the mathematics. So the word algorithm comes from the name of 9th century Persian mathematician. Persian means Iranian mathematician, currently Iran. Okay, Al-Khwarizmi. Al-Khwarizmi. He has given he has contributed enough in the mathematics field. Okay, in fact even the word algebra is also derived from a book he wrote called Hisab al-Jabr. Okay, algebra that we are reading and also we will read in our senior classes. Okay, and throughout the life was credited by Muhammad ibn Musal al-Khwarizmi. Okay, between 780 to 850. Okay, after the birth of Christ. Okay, fine. So a lemma is a proven statement used for proving another statement. Lemma is just like an axiom. Okay, axiom, you know, in your geometry. Axiom means this is the kind of statement which cannot be proved. Okay, it can only be understood with our basic intuition or basic logic. Okay, which our brain says that it is correct. Okay, we cannot prove it. We can only understand it. So such things or such statements are called axiom. So in number system we call this lemma. Okay, so lemma is a proven statement. Okay, used for proving another statement. It is telling that it is a proven statement, but uh, axiom is also a proven statement, but we cannot completely prove. We prove by using some reasoning or by using mathematical induction. Okay, means by giving some induced terms. It doesn't mean that it we can completely prove it. Just like it is quite basic or intuitive. Just I am giving the example. Suppose 2 plus 2 is equal to what? Not 5 but 4. It always be 4 even in the anytime. Okay, so this is lemma, this is the axiom. Okay, we know, our brain knows that 2 plus 2 always give what? 4, not 5. Okay, this is quite basic, but this is the root of mathematics. Okay, after then we can understand anything else. Fine. So see, what is the application, you will say, sir, because we are understanding this that why, uh, because we need to understand HCF. You know, in every exam, in everything, HCF and LCM creates problem to us. Okay, highest common factor and least common multiple. So this credit goes to Euclid's division algorithm. Okay, recall that HCF, you know, HCF, as the name suggests, highest common factor. Okay, between any two numbers, suppose 40 and 30, what should be the common thing between two of them? Okay, we can easily say by getting its prime numbers. Okay, prime factors. Okay, what is prime factor? Prime factor, you know, the prime numbers which cannot be further divided by any other number except itself. Okay, or 1. So 40 can be written 2 to the power 3. Okay, pardon me if you are unable to see. 2 to the power 3 into 5. So its prime number is 2 and 5. And so 30 can be written 5, 2 into 3. Okay. So what is common between these two things? See, 1 5 is common. Quite easy, basic. Any layman can say. Okay, 5 is common. Here 1 2 is common. Not all 2 to the power 3, but only 2 is common. Okay. Here is also 1 2 is common. And 3, no, 3 is not common. Okay, because here is 3 in 30, but in 40 it is not. So LCM should be 10. Fine. Sorry, not LCM, HCF. Okay, pardon me. HCF should be 10, highest common factor. Okay, because means see, common is in both the number. 2 is also common, 5 is also common. Okay, but what is the highest thing that is common? The highest is 2 into 5. This is the highest number. Hence, it is called highest common factor. Okay, quite easy. And for LCM, I will tell you if it will come. Okay, step by step. So let's read the algorithm. Okay. Step 1. Apply Euclid's division lemma to C and D, so we find whole numbers Q and R such that C is equal to DQ plus R. Okay, first we need to apply Euclid's division lemma. Okay, means any number can be written any integer, I mean to say can be written any another integer plus if there is any remainder. Okay, okay, and remainder should be always less than the divisor. Okay, you know, dividend, divisor, and quotient and remainder. I think these are the uh, these things must be taught before class 6 and 8, 7. Okay, and the step 2, if r equal to 0, okay, d is the HCF of C and D. Okay, if r is 0 means remainder is nothing. Okay, means d is the perfect factor of C and D. Okay, so sorry, yeah, C and D is the perfect factor, so D can be the HCF. Okay, if r not equal to 0, apply the division lemma to D and R again. Okay, the C divisor that we have is D and the remainder. If we get the remainder in the very first step 0, then we do not need to apply or do any further step. Okay, or algorithm. We can easily say this is our HCF. HCF should be D. Okay, I will give you with describe the thing again with the example, but let's first understand the step. But if there is suppose remainder, okay, any remainder, then again we will do what? We will take the remainder and the divisor, and we will again do the same Euclid's division process. Okay, with d is equal to, will again give, suppose d will give e times m, suppose any variable r1. Okay, again r1 is not 0, then again we will take d e1 and r1. This process will continue until and unless we will get what? This remainder 0. Okay, and what is the means benefit? After that we can find the very step in which the remainder will become 0. We can say that the particular divisor is our highest common factor. Okay, it is written in the step 3. Continue the process. Pardon me. See, continue the process till the remainder is 0. Okay, till the remainder is 0. The divisor at this stage will be the required HCF. Fine. Yeah. Now enough for theory. Let's come to the example. Suppose we need to find HCF of 4052 means 4052 and 12,576. Okay, so which is the greater number? 12,576. So obviously we will take this as dividend and divisor should be 4052. Okay, it's quite obvious. Then you can do on your own self. Okay, for it will be 3 times, but it will give one remainder. Okay, which is 420. So 4052 is not there HCF. Again we will do what? We will again take 4052 and 420. Here 4052 will be the dividend C and 420 will be the divisor. Okay, and 420 will be multiplied. Okay, you can check on your basic division and multiplication by 9. Also it will give 272 as remainder. Again remainder is not 0, then we will again take what? 420 and 272. Okay, and here 420 will be the same thing. I am not going to repeat. Here again remainder is 148, again 272, 148, again in the last C we are going to get 24 here as the divisor and 4 as the remainder. If we take 24 as the dividend and 4 as the divisor, we are getting a remainder which is 0. So s- can you say what is our HCF? Means what is the HCF of this particular grouping of numbers? HCF is 4. Okay. So hence we are getting the HCF of this is 4. Okay. Quite cumbersome step, but this is the actual funda through which we can find any HCF. There is a shortcut also, but I will describe in the upcoming time. Okay, okay, I will describe now. Leave it. Not a big deal. First, remove everything. Shortcut is shortcut. Not. It is also based on the step. There is nothing means shortcut in the maths. Everything is based on algorithm logic. So keep dividing. 3 times we know 12. Okay, see. Okay. Here should be 3. Here should be x 1 5. Okay, can you see? Okay, then subtract this. After subtraction, this is the subtraction process. This will be 0, 2, 4. Okay, 420c, same thing. 420, 405 to same thing, but in a faster way. Now 420 is going to give this, so it can be written here 4052. Again we will divide. Same process will go, and with this we will get that finally we are getting 4 as HCF. This is the same thing but in a different approach. Now there is third approach. Okay, these were two approach. Now let's discuss the third approach. 12, 5, 6. Write down the given number in their prime factor. Okay, so you can see 2 is common. Okay, and in 4052 see both are I think divisible by 4. See, for divisible, the condition for divisibility by 4, the last two digit should be divisible by 4. So 76 is divisible by 4. 52 is also divisible by 4. See, I am giving you some fastest way, but it's not that fast. But you shouldn't try in your board exam. But for your competition, you can do this. So it is also 4. Okay. After 4, what should be the number? 4. Wait. 312. Okay. 4 1 is 4. 1. 4 4 16. 4 4 16. Okay. And it can also be written into 10 13. See, it can further be written down on any other prime number also. Okay, not prime number, any further it can be further factorized. But see, 1013 3 4 5, it is not divisible by 3, it is not divisible by 4, it is not divisible by 5, it is not divisible by 6 and 7 8. You can try on yourself. Okay, even for 9. So we are getting common factor only 4. Okay, this is the particular number which is not divisible by any number. So and so. Luckily we have find. So we are finding here is also 4, here is also 4. This is highest common factor. 1 will be the factor, but highest is 4. It can be further written down, but in the fastest way we can easily say this is the common thing which is in both number. Okay, so it should be our HCF. So should be our HCF. This is the fastest way. Okay, within a second you can find. But this is the this shouldn't be done in the board exam. In the board exam, and we should follow the basic step. Fine. Okay. The thing that I am teaching is also helpful for SSC examinations. Okay. In SSC, it is also asked for the tier 2. Okay, because 350 marks of maths is in for SSC CGL. Okay, combined graduate level. So they can also take their help. Okay, for the trick for tier 2. Okay, complete 9 and 10 maths ask completely based on this basic things. Okay, trigonometry and geometry and number system. Now see example 2. So that every positive even integer is of the form of 2q, and that every odd positive integer is of the form of 2q plus 1, where q is some integer. See, they are telling so that every positive integer means I plus one, two, means every natural number in short. Okay, without passing any time. Okay, every natural number, and but it is also asking now it is the basic positive integer, and even integer means even natural number. Okay, even natural number means 2, 4, 6, 8, and so on. Okay, so this would be in the form of 2q. How can we say? Okay, see, there are so many ways. Okay, first way is see, 2 is itself in the form of 2q. Why? It can be written 2 into 1. 4 is itself in the form of 2q. Why? It can be written 2 into 2. 6, 2 into 3. 8, 2 into 4, and further. Okay, all even integer can be written 2 times any other integer. Okay, positive integer. Okay, so any other positive integer can be written in a means final manner or in a summarized way. These three. Okay,